Hi, again. Welcome back. We're going to jump into the 3D tutorial, which is the second part of the certification process. The first couple pages of the tutorial, which I have here brought up from the Making It GSAP website, where it's posted under CNC required training, has a little bit of review and terminology and types of cuts from the first one. So I'm going to assume that we are semi-familiar with that and go right into positioning the piece and setting it up. So when you're working with a three-dimensional object, it's clearly a little bit more important to get bearings right in the z-axis because you're going to be working with a thicker object, thicker material, more potential for sort of collisions. What I like to do is set up some guides that you're going to work with your object throughout the entire process. So you can do this manually or without any guides if you just sort of eyeball it in the different viewports in Rhino. But for clumsy people like me, I like making a bounding box around an object that I want to mill, extracting a wireframe of that object, and then grouping the wireframe. This gives you just an easy XYZ extents of your object to work with later. So you can see in this working file I already have it positioned somewhere good, but let's assume that I haven't done that already. Here in my separate, remember, working RhinoCam file from my modeling file, I've already sketched a box of the material that I want to work with. I know that beforehand in this case that I want to work with a 6" by 6" by 3" block of foam that will be available for you in the shop. I might not know, however, after modeling my object, how big a block of material that I need to use to cut it. So how do we figure that out? Well, the same principles apply from the 2-axis tutorial, which is that in the XY extents of your model, you should have about an inch of space around it to work with, to secure things down, to screw it into the table. So if I give this an offset of an inch, you can see I've already conveniently modeled my object to fit within this material box that I've already drawn, with an inch of play around the outside of it. As for actually positioning it, start by backing it into this corner of 0, 0, 0 and below the XY plane, below z equals 0. Now if you look in the tutorial, you can see it tells you about building a bounding box around your object. It has a little detail about making sure that there's a little bit of daylight in Z between that XY plane, between that origin plane, and where the top of your object is. This is because the act of zeroing the bit to the surface of your material is slightly imprecise. You want to make sure that you have a little bit of daylight there, a little bit of material to cut through before you get to your part, so you don't accidentally leave some of your part out of your material, especially if your material has an uneven surface, which a lot do. So looking in one of the side or front views, what I do is I just make sure to have moved my CNCing object slightly below z equals 0. You can see here I've conveniently made an object that's just slightly less than 3 inches, so it fits perfectly in our box. But that's not necessarily the case. You might have an object that's, say, only this big, and that's the material that you have to start with. If you're concerned with maintaining the thickness of that object as you have it modeled there, remember it has to be pushed to the bottom of your stock to cut it correctly. Try to be economical with this. There's really no good reason to blow through 2 inches of material to get to a 1-inch object that you're cutting. But we're going to use the full-size object. And then finally make sure that it's positioned in XY with that good 1-inch perimeter around it before you get to the edge of your material.